Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called Iceland perimeter. So in this problem we have been given a grid that contains 1 and 0 and it is two-dimensional grid like this, and we need to find the perimeter, right? And we can move like horizontally or vertically but not diagonally, right? So let's see what does that mean. So these brown cell, if we see here, they all are one, right? So they all are land, right? So the brown thing is land, and this blue part is zero here. I think this is a pretty good diagram. From this diagram we can understand what the perimeter means, and these yellow lines, that is basically perimeter, right? So if we count all these yellow lines, they are 16 in this particular case. So I think problem is pretty intuitive to understand because of this nice diagram, right? Now we need to think like how to solve this problem, how we can solve this problem. So first thing is we just care about the one, right? Because one is having all the surrounded this yellow part, right? So that is the first observation. So if we consider only the cells that contains one, then we can at least start our implementation, right? So that's one thing. Another thing is like when we start from the grid that contains, not the grid, but if we start from the cell that contains one, then we can look around, right? We can look around, okay, what is my neighbor? So I have two neighbors and that contains zero, right? So at least what I can do, if I take some counter or something, right? If counter is zero, then I can increment this counter by 2. So I can increment because it's this is neighbor is 0 and this another neighbor is also 0. And if I say upward, that is going out of matrix, then also I can increment this counter by 1. Why I am doing so? Because the observation here is whenever the neighbors are 0, then it means that contains one perimeter. I mean the I can consider it as a one count. I can increment safely by 1, right? I can safely increment my perimeter by 1. And similarly, if it is going out of matrix, means if it is on the boundary, not exactly, it is not exactly going out of the boundary. What I mean to say, whenever we will handle such condition, we will check, okay, if it is crossing the boundary, right? It means it is on the boundary, then also we can increment our counter. So let's do this. Okay, let's go ahead and note down such observations. Okay, so first of all, check for the cells for one value, okay, because they are the land. Okay, now what we need to do, check neighbors, right? Check neighbors if they are 0 or, right, if they are 0 or basically it is, or cell is on boundary, right? And how we can check current cell is on boundary or not? We can check if it is going out of boundary, right? If it is going out of boundary, then it is basically uh, it is on the boundary itself, right? So basically here these are the two observations I can see. Like this is the first observation, and if I choose here the different color here, this is like the first observation, and then this is the second observation. Okay, so if we can consider these two observations, I think then we can build our algorithm, right? Because obviously we have to start from 0. I mean we have to start from the cell that contains 1, right? Not 0. 0 is the water and 1 is the land, so we need to start from the cell that contains 1, right? Because that will be surrounded with the water, right? And that's how we need to find the these yellow lines, right? Yellow lines here are the perimeters. So if the neighbors are 0, right? So if the neighbors are 0, right, then we can increment our counter, and the current cell is on the boundary, right? So if the current cell, for example this cell, this one cell is on the boundary, right, then in that case is also we need to increment our counter, right? So if it is neighbors are 0 or it is on the boundary. So this current cell, if it is on the boundary, means it is on the boundary from the upside. For example, this one cell is on the boundary from the left hand side. Now we can consider these observations. Now how we are going to solve this problem? So what we can do, we can have our 4 direction. We can just get the basically 2D grid or 2-dimensional grid that will have the 4 direction, right? So in the 4 direction, what does that mean? If this middle point is 0 0, then basically this will be 0 1. Upper part would be this will be 0 1, and then this will be 1 0. Why? Because x axis is basically this part, so x axis is at the 0, and here the x axis we are incrementing by 1, and this is 0, right? And then similarly this also 0 -1, and this is -1 0, right? So if we can take all these coordinates, all these 4 coordinates for the left, right, up and down, because it's saying that it are connected horizontally but not diagonally, horizontally and vertically. So if we take all these 4 directions, we can start our searching from the one, from the cell that contains 1, and then we can move all these 4 directions. And once we get these conditions, right, once we get these conditions means if we already, we will be checking if it is 1, and these neighbors are, if they are 0, and if the current cell is on the boundary, then we can increment our counter. So I think if we can understand this thing here, then I think code should be straightforward. But let's go ahead and create couple of placeholders here, so that it will be little bit easier to understand what we are trying to understand here. So here this is like base condition, okay? So if my grid is null itself, then definitely there is no perimeter, right? And let's take grid length as well, and let's take here grid 0 dot length. Okay, so let's take directions 2D as well, as we have seen, right? So let's do this. This is here 0 comma 1, 1 comma 0, 0 comma -1, and then -1 comma 0. Okay, now let's go ahead and traverse this 2-dimensional grid, and then I plus plus. Second for loop will have j pointer, j equals to 0, j is less than n, j plus plus. And if this grid, if this grid cell contains 1, right? So that's what we learned from here, right? We need to start from that cell that contains 1, so that we can just look over the neighbors. Then what we are going to do, we will just look all the 4 directions. So now we will use this 2-dimensional array that we have created, and then we can take the coordinates here. So what we can do, I is our current coordinate, and then we can try to add this x and y coordinate from this direction, 0 1 1 0, and 0 -1 and -1 0, right? And then j plus direction 1. So this is y coordinate. Okay, so these 4 coordinates we are adding in the current coordinates. And now let's go ahead and check if this x is less than 0. What does that mean? Less than 0 means -1, right? So if it is -1, then it's crossing the boundary, because if it is on the boundary, it should be 0, right? But if it is going -1, extreme -1, then it means it's crossing the boundary. Then this is the time that we can increment our counter, right? So let's go ahead and take counter as well, or in fact I can take counter here itself in the starting, int count equals to 0, and then go ahead and return counter. So here it will be 0, and after this condition I will do count plus plus. So I need to still fill this condition, right? So even if x is less than 0 or x is greater than m minus 1, or m minus 1 is because it's length, so m minus 1 I'm doing because it's index based, right? So we need to do -1, m minus 1. Similarly, if y is greater than n minus 1, and similarly if grade x by. So when it will come to this or condition, whenever these all are the false, right? False means if they are the valid coordinates. right? Because it's oring. We are using the here the or operator. Or operator means if it is basically false, then it will check whether this second condition is true or not, right? That's how it or works, right? So if it is false, then it will come here. If it is false, then it will come to the third, and then if it is false, then it will come to the fourth condition, and this is also false, then finally it will come here. So that in this way we will not get index out of bounds exception here. It means x and y is valid here. Okay, so it is safer to use x and y here. Okay, and if it is 0, then we will go ahead and increment this counter, and this counter will count these yellow lines, and these yellow lines, the total count of yellow lines would be our answer, our output, right? So I think that's what exactly we were discussing on the whiteboard. Let's go ahead and return count here itself. Quickly, the time complexity and space complexity wise, it will be we are traversing here all the way, all the grid, right? This 2D dimensional matrix, and then we are traversing through this directions map as well, 2D array map. I am saying because I am using this position 0 1, so this is not the hash map, but this is the 2-dimensional matrix. But basically this is again the constant size, so still the time complexity would be m into n, and space complexity would also be m into n here. Okay, why space complexity would be m into n? Because uh, here we are taking the constant size, so we can argue that it might be 1 as well, right? Constant, because here really we are not using any recursion or anything, and then this is also the constant size, so we can say okay, yeah, this will be order of 1. Let's go ahead and check for the compilation error if there is any. If there is not any, then let's go ahead and try to submit, and let's see if it is working. So looks like this code is working fine. Another approach might be uh, rather than doing this by this code 2D dimensional matrix, what we can do, we can use the depth first search as well. So what we will do in the depth first search, we will still do the same thing. So this caller method would be the same, right? It will still, we will be traversing like we will be using 2 for loop because it is the 2-dimensional matrix, and we will still be starting our search with a grid that contains 1, means that is land. But rather than traversing all these 4 directions, basically what we can do, we can start the DFS means like we will just look around, we will have the base condition the same way, whether it's crossing the boundary or if the neighbors are 0 or not, right? In that case we will be incrementing our counter. But in addition to that, we have to put the visited thing as well, because in the DFS we cannot basically we cannot we cannot overfill our implicit stack, right? So we need to maintain the visited array, so that at least the one cell we will not visit again and again, right? So we can avoid the stack overflow exception as well. So that's another thing basically we can try, and then we can just do the counting. Let's quickly uh, try to do that as well. And so let's say to here the DFS here, great. Okay, I comma j, and here this count 0, what we can do, we can make it global. Why global? Because this count basically we can fill in our helper method, DFS method. Okay, so once we will enter in DFS method, so let's say we pass this cell, and our DFS method will just go ahead and just try, we will just go deep and then basically recursively visit every cell right here that contains 1, and then it will keep finding these scenarios, whether it's crossing the boundary or the neighbors are 0. In that case it will keep incrementing the counter, and then once this DFS, once we will out from the DFS, then basically we can immediately return counter here, right? So that's the idea basically. Okay, now this DFS will be like pretty standard, so there should not be anything special in this DFS, rather than we can just take another boolean here as well, because as I mentioned, we need to take the boolean because of the visited. We need to keep a track of the visited as well, otherwise we don't want to visit this one cell again and again, right? So let's take grade here. Oops, grade int row, int column, and then boolean visited. Okay, now let's have the base condition. So base condition is same, row is less than 0, row is greater than grid dot length -1, column is less than 0 or column is greater than grid 0 dot length -1, or grid row column if it is 0, right? In that case we will increment the count and then we will return from here as well, so that whatever the code we will be writing here, that will not throw the index out of bounds exception. So what, whenever it's going extreme left extreme right, means if it is going out of boundary or if this kind of situation, then we are just returning also as well, so that we are safe here, right? Because this is the base condition as well, and it's serving the purpose to increment the counter as well based on our condition. Now here we can check our visited thing as well. So if visited, it is not visited, it is visited, right? So if it is visited, basically row column, and if it is visited, then basically go ahead and return from here as well. Otherwise mark this as a true, row column true. And now let's go ahead and call DFS row +1 column visited. Okay, now let's call this for all the 4 directions here. Row +1, row -1, row column +1, column -1, and that's it. That's pretty much it. So let's go ahead and do that. Let's go ahead and try to solve the compilation error if there is any. If not, then basically here the space complexity would be m into n. Why? Because here we are using the recursion. So recursion will be doing the implicit stack as well, and it will be we are maintaining this visited array as well. So we are increasing our space complexity as well, right? So that's why it will be the order of m into n. Let's go ahead and remove this part. So it was compiling fine. Let's go ahead and try to submit and let's see. So this is also working. Okay, so this is fine. So if you see, like, very slightly difference is there because of recursion, so little bit performance got degraded. So you can use any approach. The idea is same. We will start from the grid that contains 1, and then we will look around all the 4 directions, right? And this is recursive approach, and earlier was not recursive, it was iterative approach. So feel free to use any of them. They both are similar, right? uh, the earlier one was little bit easier to understand, not easier, but I would say it was iterative, so we don't have to deal with the recursion, and we are not unnecessarily doing the implicit stack here. So we can solve that in the complex constant complexity, space complexity itself, right? So that is pretty much it. Basically, quick summary before ending this video: once we get this diagram, we need to, like, first observe, like, what are the facts here that we can collect. And the facts are basically we have to collect the yellow line, we have to count the yellow line. And how we will count the yellow line? The basically starting point will be the cells that contains 1. So we need to start from the cell that contains 1, and we will start from our search, and then we will look around all the 4 directions, left, right, up and down, and then we will see, okay, if the neighbors are 0, right? Similarly here we will start from the cell that contains 1, and then we will check the neighbor if they are 0, or if it is the current cell is on the boundary. That is the basically main concept of this problem. Once we get this point, then basically we just need to convert that thought in the code. Either we can do iteratively or recursively, it does not matter. So I hope this might be useful. Thanks a lot, have a good one, bye.